Hello, geometry. Here is your 11.6 video lesson. 11.6 talks about spheres and their volume and their surface area. Here are just some examples of spheres we see in our everyday life. Basketball, bubbles, a giant beach ball, I'm not really quite sure. This looks like a human hamster, this guy right there, hamster ball, excuse me. And then obviously, planet Earth. All right, so let's just talk about some vocab here. Maybe let me get rid of this dotted line. There we go. Okay, never mind, still there. Anyways, so here is our just diagram of a sphere. Our center is pretty self-explanatory, it's in the center. Our radius goes from the center to an endpoint outside the sphere. And then a diameter would obviously go from one endpoint on the sphere through the center through another point on the outside. And then some other vocab here to talk about. The circumference of a sphere is a great circle. Now I'm assuming some of you don't know what a great circle is. And all a great circle is if it's a circle that intersects our sphere, like so right here, and its center is the same as the sphere. So obviously we don't have two of these, one that goes horizontally and then another one that goes vertically, which is really hard to draw on here, but it'll go up and down. Anywho, a great circle divides a sphere into two hemispheres, which would be equal parts, that's halved. And like I said, that circumference is the great circle. So the key thing to for this lesson is we'll be able to find the surface area and volume of a sphere to know its radius. That radius plays a pretty significant role. So here we are. The surface area of a sphere is 4 times the product of pi and the square of the radius. So let's just write that down. 4 pi r squared. So if we were to try this right here, it says, what is the surface area of the sphere in terms of pi? Well, you know that my radius is 5, half a 10, so surface area equals 4 pi r squared. Plugging in our radius, we get 5 squared is just 25. And 4 quarters makes $1, so 100 pi meters squared, remember, still area. A little geography here. Earth's equator is about 24,902 miles long. What is the approximate surface area of the Earth? So that equator is actually our great circle's circumference. So we're told right here that the equator is the circumference. So remember I said that radius is a pretty big role today? Well, the circumference we can find its radius and plug it in to find the surface area. So let's remember, dig into our memory bank, circumference equals 2 pi r. Now let's plug in what we know. 24,902 equals 2 pi r. Okay, now we just want to get r by itself, so we're solving for r. So we're going to divide by 2. Get 12,451 equals pi r. Now divide by pi, and we get 3,963.27. Okay, now the next part it says, what's the surface area? So that's what we're looking for. Remember, surface area equals 4 pi r squared. Plugging in, 4 pi 3,963 we'll round to 63. All right, squared. Now squaring that, we're going to get a really large number here. 15705,369. So 15,705,369,000 times 4 pi is approximately 197,300,000 359,488 miles squared. Depending on how you round it here with your radius, and if you use pi or 3.14, your answers might vary. As long as your ballpark close enough, I think we're in good shape. So, you don't have this in your notes, so why don't you write this down right here. The volume of a sphere is 4/3 times pi times the radius cubed. Which makes sense because when we work in volume, our measurements are always units cubed, so that would make sense why our radius is cubed. All right, so again, that's 4/3 pi r cubed. What is the volume of the sphere in terms of pi? Let's just plug in. Volume equals 4/3 pi r cubed. Plug in our r. 6 cubed, simply just 216. Now, if you don't know how to go from here, all you're doing is multiplying two fractions, right? Because this is technically over 1. So you take 4 times 216, and let me see here. Okay, we get 864 divided by 3, and we haven't done anything with the pi yet. All I do is take 4 times 216. Now taking 864 divided by 3, we get 288 pi meters cubed. And again, they wanted our answer in terms of pi. All right, it says, reasoning. Suppose the radius of a sphere is half. How does this affect the volume? Well, just to make our life easier, we just use 6 as a radius, so let's just do half that. Let's make it 3. So, here we go. Volume equals 4/3 pi 3 cubed. 4/3, 3 cubed, we all know is 27. Now, 4/3 of 27 is, hold on, let me figure this out. Hold that thought. I don't have it in my notes. 27 times 4 divided by 3 is 36. So we get 36 pi. Now, I don't know how many times bigger something is. Well, simply we just take how many times does 36 go into 288? Our pi's cancel, so 288 divided by 36 equals 8. So, that being said, it's 8 times smaller. Okay, moving right along here. It says the volume of a sphere is 5,000 meters cubed. What is its surface area to the nearest square meter? So we're given the volume and we want to end up with the surface area. So remember, we need to find the radius. All right, so let's see how this goes. The volume is 4/3 pi r cubed. Plug in 5,000. Now we need to isolate the r, so we're going to take 3 times 5,000 and get 15,000. 4 pi r cubed. Divide by 4, and we get 3,750. Pi r cubed. Dividing by pi, 1,193.66 equals r cubed. Now, how do you undo something cubed? You take the cubed root. So we end up with r equal to 10.6. Now, plugging this into for surface area, here we are, 4 pi 10.6 squared. Well, 10.6 squared we find is 112.36 times 4 pi gives us approximately 1,411.95. And that's the nearest square meter. So 1,412 meters squared. Okay, turning the page here. The surface area of a sphere is 64 pi square centimeters. What is its volume? Again, now it's the same problem, just the reversed way. We have the surface area and we want the volume. So surface area equals 4 pi r squared. It's 64 pi. So divide by 4. So you apply here. So let's just get rid of what we can right away. Pi's go out, they cancel. Now 64 divided by 4 is 16 equals r squared. Taking the square root, 4 equals r. Now plug in that for our volume. So we're going to have 4/3 pi 4 cubed. Then we're going to cube that 4 and we get 64. And 4/3 of 64 is 2. 156 divided by 3 pi. Dividing by 3, we get 85 1/3 pi, which is approximately 268.1 centimeters cubed. So again, all we're doing is looking for that radius. Once you find it, you plug it into a different equation and go from there. All right, so we have here the sphere at the right fits snugly inside a cube with 18 centimeter edges. So all of our guys are 18. What is the volume of the space between the cube and the sphere? I think your answer is in terms of pi. Well, we're looking for this space in between these guys, so I think it would do us justice if we just found the volume of both and subtracted them. So let's start with the volume of the cube. So remember, a cube is just base area times height. So my base area is just 18 by 18. So 18 times 18. And it has a height of also 18 because it's a cube. So 18 cubed is 5,832. Now going to our sphere here, volume. Sphere. That's 4/3 pi r cubed. And, well, we're going to find our radius. Half of that, right? So what's half of 18? 9er. Plug it in. 9 cubed. Well, we know that 9 cubed. Hold on here, let me catch up. It's 729. 4/3 of 729 gives us 972 pi. So then we have, we want our answers in terms of pi. Well, it's pretty simple here. 5,832 minus 972 pi centimeters cubed. It says the density of steel is about 0.28 pounds per cubic inch. Could you lift a solid steel bulb with a radius of 4? What about with a radius of 6? So first we need to find the volume, how much mass we're dealing with here. So let's go with this 4 guy first. So volume, 4/3 pi 4 cubed. So I'm going to have 4/3 pi times 64. Now we already done this before, so 4/3 of 64 is 85 1/3 pi, or approximately 268.1. So now to find how much it weighs, we take it times its density. So times, it says steel is 0.28 pounds per cubic inch, and we get a total of 75.1 pounds. So depending on how strong you are, I'm going to say yes / maybe. Most guys, I'd say yes. Some girls, I don't know. I hope I'd be able to lift 75.1 pounds, but I honestly don't know if I could. Now, trying this with a radius of 6, let's see here. 4/3 pi 6 cubed. We find the b, 4/3 pi 216. 4/3 of 216, we know is 288 pi. And then that's approximately 904.8. And again, take it times our density. And we get a total of 253.3 pounds. So I'm gonna say no. An average one of us probably wouldn't be able to lift that. So maybe some of us would, but I'm gonna guess and probably say probably not. Now to round out this lesson here, we're gonna finish with this plastic ball problem. How much plastic would be needed to make a water ball with a diameter of 2 meters? So what's the size? That surface area or volume? Or we need the material to make this plastic ball. That'd be surface area. And it has a diameter of 2, meaning radius equals 1. Plugging in 4 pi 1 squared. 1 squared is just 1. 4 times 1 is just 4 pi, which is approximately 12.7 meters squared. All right, guys, thanks for watching. Let me know if you have questions. Have a great rest of your day.